Artificial intelligence is used more and more. So much, in fact, that we often have no idea what algorithms are being used for. As long as they work well, that might not be a problem, but when there are adverse impacts from algorithms, it can be hard to correct these if you have no idea that there's an algorithm behind it all. And so governments, and in particular the European Union, are stepping up to require transparency about the use of algorithms as soon as they pose risks to the people affected. To arrive at this transparency, governments are mostly turning to algorithm registers. Roughly speaking, these are long lists showcasing the different algorithms that are in use, along with information about these algorithms. They're publicly available, for example, for the municipalities of Amsterdam and The Hague, and their goal is usually not just to inform people, but also to justify the use of these algorithms. Amsterdam, for example, provides information on the datasets they used, the way they processed the data, the steps they took to prevent discrimination, their measures to ensure human oversights, and any additional steps to mitigate ethical risks. Together with the goal and use of the algorithm, this is meant to give a good overview of the way they use algorithms and thus to allow the public to decide if they find this acceptable or not. However, as you will notice while reading these registers, they are very focused on the processes employed in the use of algorithms. They will tell you what measures are taken to prevent biases, but there's usually no information on how successful those measures were. Nor do they tell you how accurate the algorithm is or how effective the chosen form of human oversight really is. Their approach to transparency is, in other words, process-based. An alternative from the academic literature is to focus not on the process but on the results. And it is those results that are central in an approach called design publicity. The idea here is that there are 4 important steps to consider in transparency about algorithms. First of all, there's the goal for the algorithm. What problem is it supposed to solve? They call this value transparency. And while it's not explicitly part of the original paper, I think we can understand this a little more broadly than just the performance goals we have for an algorithm. All the different values that we can have for algorithms can be part of this kind of transparency, whether it's accuracy, fairness, effective human control, or another value. If you want to show that this algorithm has been developed responsibly, it's a good idea to show what has been taken into consideration. However, just showing that you have certain values is not enough, and that's where the next 2 parts of this transparency framework come in. As part of the translation transparency, you are asked to make public how these values have been translated into concrete requirements. Specifically, the idea is that you show how you are going to establish and ideally measure whether the end results realizes those values. What tests will be done to ensure that the AI is acceptable for use? That's the question to start with, and the natural follow-up in the form of performance transparency is to tell the public how the algorithm performs on those tests. Did it pass with flying colors, or are there still concerns about some of the values we would like to see? By showing the performance on the chosen metrics, the argument goes, one can justify the use of the algorithm. The only complication is that the performance of algorithms usually changes over time. For example, algorithms estimating risks for loan applications had to be adjusted after companies failed to default on debts during COVID. Performance had declined, and so it's important to not just measure this performance once, but to keep doing it to maintain quality. Hence, there's this last bit about consistency transparency. Algorithms will be retrained to keep them up to date, and being open about how that happens and to what effect is an important final step to offering this kind of transparency. You can thus essentially approach transparency in two ways. On the one hand, you can offer information about the processes that are in place. That can be the algorithm itself, but it can also be the data collection or the steps that are taken to mitigate risks. On the other hand, you can inform people about the performance of the algorithm. What do we want it to do, and how well does it do so? Of course, there's no need to pick one of the two, and combinations are possible. But there's also no guarantee that this tells us everything we'd like to know. There is, for example, no mention so far of conflicts between values that require trade-offs between the different measures that are used. That too can be very valuable information when trying to decide if an algorithm is designed and used in a responsible manner. And vice versa, perhaps we can't be transparent about everything. Some algorithms, such as those in the national security domain, might perform better when it is not publicly known what they are doing. That being said, transparency is usually a good thing, and with these two approaches, we have a strong starting point for realizing it in practice.